It is section 8.4, DBSCAN, density-based clustering. In density-based clustering, clusters are defined as areas of higher density than the remainder of the data set. The objects in sparse areas are usually considered as noise and border points. The most popular density-based clustering method is DBSCAN. DBSCAN groups points that are closely packed together given a set of points. It's one of the most common clustering algorithms and also most cited in scientific literature. It has citation number 28, a little more than 28,000 as of today. In 2014, the algorithm was awarded the Test of Time Award at the leading data mining conference, Knowledge Discovery and Data Mining. It's a really good algorithm. Okay, here we consider preliminary for DBSCAN. We start with a data set to be clustered. Choose a number epsilon, a parameter which is specifying the radius of a neighborhood with respect to some point. And in DBSCAN clustering, the points are classified as core points, reachable points, and outliers as follows. A point P, that is a definition. A point P is a core point if at least M points are within distance epsilon of N, including P itself. And we'll see it in soon picture, and I'll try to explain it. Point Q is directly reachable from P if point Q is within distance epsilon from a core point P. So the directly reachable point must be reachable from a core point. And now a point Q is reachable from P if there is a path, so that now here the Q is reachable from P through path, but each point during the path must be core points. All points not reachable from any other points are outliers or noise points. And a core point forms a cluster together with all reachable from the point. And each cluster contains at least one core point, and also some non-core points can be included. They are edges, or sometimes it is called border point. Okay, here for the algorithm, epsilon is the radius of a neighborhood, and M, that is the minimum points, the minimum number of points in the epsilon neighborhood. We'll see this picture. Here, point A, that one, and 5 other red points are core points, because if you try to make epsilon ball, then for A, you'll see 4 points. When we are choosing M is 4, there are 4 points here. For that point, we have 5 points, so at least 4. And for this one also, at least 4, so that this all here in red points are core points. Okay. Now here, B and C, for example, around B, if you make epsilon ball, then now you have only 2 points, so there is not a core point. However, from this one, it is reachable. So it is within the epsilon distance from a core point, so it is directly reachable from this point. Of course, this B is reachable from A because there is a path. You can go this way or you can go that way, and B is reachable from any of these core points. Similarly, C is not a core point because an epsilon neighborhood has only 2 points. However, it is reachable from this core point, so that it is reachable from the core, so that it makes a border point and boundary edge. Basically, it is edge. Okay, and N over there, N epsilon neighborhood has only a single point itself, and it is not reachable from any core points, so that it is considered as a noise point. Okay. In this way, we try to classify the points given M and epsilon and try to make clusters including the core points and border points. Okay. Here, reachability is not a symmetric relation. For example, B is reachable from this point, but this point is not reachable from B because the reachability is defined. It starts from a core point. Now, B is not a core point, so that you cannot here reachability from B. Here you see the arrows and both way. So that means it's reachable here, and this one means both way reachable. So you can distinguish now the reachability is not a symmetric relation. Okay, now we define here density connectivity. 2 points P and Q are density connected if there is point C such that both P and Q are reachable from C. That means that C must be a core point. Once from core point is reachable, then we say that the target points P and Q are density connected. And density connectivity, the density connectedness is symmetric. Quite easily you can check that. Here, a DBSCAN cluster satisfies 2 properties. All points within a cluster are mutually density connected. This means that a cluster is formed so that every point inside a cluster will be mutually density connected. If a point is reachable from any point of the cluster, then it's part of cluster as well, which means that it is including all reachable points. And either way, you may consider the concept for DBSCAN clusters. And also with this one, you can make algorithm for DBSCAN. Okay. Here we have a pseudocode. And here, okay, start with empty cluster. There's no cluster yet, and 0 cluster. And for each unvisited point P, and once you visit, then mark P as visited and try to find neighbor of P. Once the size is less than M, then mark P as noise. If is at least M points are there, then now here the cluster, the first cluster, so that C is added by 1, so that now it means here we have one cluster now, and then from P and MP we expand. So here now, okay, first we add P to cluster C, the first cluster in the beginning, and for each Q in the neighborhood, if Q is not visited, then here, after visiting, now again, try to find the neighbor of the Q, and now once the neighbor size is larger than or equal to M, then now we here the join that MP with NQ must be joined, so it is expansion, so that along with that you can expand the cluster. And if Q is not yet member of any cluster, then add Q to cluster C. And because Q is a neighbor of P, so it is a reachable point, so that you have to add it. Okay, here, before considering this picture, let's see this one. Okay, right now, okay, here, number of points in the neighborhood is less than M, then mark P as noise, so that this line may assign noise even though it is reachable. But here, through these two lines, again, it can be corrected, so that this two line is necessary to avoid this the noise assignment. Okay. Along with this DBSCAN, here for given data set, now epsilon is chosen 10, and here M is chosen 4, and along with that parameters, DBSCAN here found clusters. Here very nicely higher density regions are found, and these green points are core points, and now blue are border points, and red are considered as noise. Okay, here we consider now properties of DBSCAN clustering. It is good with noise, and also it can handle clusters of different shapes and sizes. Epsilon and M depends on each other and can be hard to specify in many cases. This is cases when the DBSCAN does not work well. The varying densities, once the density is varying, now it is not well working. In fact, for varying densities, most of the algorithm will not work well. So it is not here only for DBSCAN. It's for almost all algorithms it can happen. Okay, also data has very high dimension, then also it can have some issues. Here for this, okay, for that data set, here along with the choice of M equal 4 and epsilon is now 9.75. But for this one, now M is 4 and epsilon is 9.92. So this epsilon, that epsilon is slightly different and M is the same. But here for the left-hand side, it is working nicely. You can see here original data. There is now triangle shape, and there is the square shape, and there is a cross shape. Now it is quite well working. However, if you are choosing epsilon slightly different, then triangle shape is here, and that is now a square shape, and remainders are the cross shape. So that along with the simple change, very slight change, you can get quite different output. Overall, DBSCAN is a great density-based clustering algorithm for most algorithms. Are not really well working when data set is hard to cluster. So that is not for only this DBSCAN problem. It's in a sense universal problem. And overall, DBSCAN is great. Okay. Thank you. This is the end of section.